Hi friends, today in this video I am going to solve the question which is in the screen. If the radius of the circle is r and the two circles have the same radius, find the area of the shaded region. This video is the continuation of the last video. If you have seen the last video, so you must have listened that I said that I am going to continue this part in the next video. So I am going to solve this question. Well, the reason is that I am not including the last video. It would be very long that video. That's why I'm not including that. So that's why I'm going to include that in this video. So please pay attention to this video. Okay friends. So first of all, I want to note some things. According to the question, the radius is r. So it means that this CP equals r and QD equals R. Well, and one thing also you have to be noticed that actually P and Q are the centers of the circle. It means that P is the center of circle and it is intersecting the circumference of the another circle. So it means that AP, PB, BQ, AQ, CP and QD all are equal. So it means if they all are equal, so I want to do an extension here. I want to draw lines here to give you a better idea. Okay. Now, so this is a line. So this is the axiom which I am going to tell to you. See, if the radius of the both circles is same, that is CP equals to be QD, so AQ and AP must be equal. They are also the radius. So this equals to this. And PQ is the radius of both the circles. So it also equals to be AP and AQ. So by this axiom, by this logic, we can say that triangle APQ is an equilateral triangle. So it means AP equals to be AQ must equals to be PQ. So if it's an equilateral triangle, so the angles must be equal to 60 degrees. So this angle equals to be 60 degrees and this angle also equals to be 60 degrees. Same logic if I apply to the down also, and if I connect this side also, so we can also say we can say that, and again I'm marking some signs, and we get triangle PBQ is also a equilateral triangle. And we can say that PB equals to be BQ equals to be PQ. So with this logic also we can say that this angle is 60 degrees and this angle is also 60 degrees. So now we have all the information to calculate that what is the angle. So okay, now I'm going to really solve it. So we have to just prove that these sides are equal because they are the radiuses, and we get the diagram. So what I'm going to do here, I'm going to clean this diagram. Okay friends, so I have cleaned the diagram now. So I'm again actually drawing the lines. Okay then, so I'm just drawing the lines, and I'm drawing the lines such that these lines are actually parallel. So what I want to actually prove that actually AQ in this case is parallel to PB. So this is for only telling, it will not help to solve the question, it is for only telling. So by proving that it is an equilateral triangle. So this angle is 60 degrees. This angle is also 60 degrees. So if I name some points like this and I name it as R and S. So as I'm going to figure out the area of these sectors. So area of the sector. Area of sector is equals to be, I'm going to take out the area of the sector, so I'm writing in the brackets, that would be Q P R A Q. So area of the sector Q P R A Q equals to be pi r square upon 360 degrees into the angle, that is theta. So in this case, radius is r itself. So I told you that according to the question it is r. So it is r here. So according to it, then pi r square would be pi r square only. Upon 360 would be same. Theta angle is 60 degrees. That is because we have proved that triangle APQ and PBQ were equilateral triangles. So after when we cancel the common factors, after cancelling we get 61, 60, 66. So we get as pi r square upon 6. Okay. Now we get area of sector. Again, this is the different sector now. It is P B S Q P. PBSQP. So area equals to be same, pi r square upon 360 degrees into theta. And again the angle is 60 degrees, so I don't have to just calculate it, it is just pi r square upon 6. So this is also pi r square upon 6. So by adding them, we get the area as pi r square upon 3. Well, I think so that you know, because when we add them, we get 2 into pi r square upon 6. So after cancelling common factors 1 and 3, so we get a total area as pi r square upon 3. But it is not the answer yet. Actually, right now we have to also figure out the area of these segments. So I'm going to color them with pink. So these are the segments which we have not taken the area of. Now we are going to calculate the area of these segments. Then we can able to calculate the area. So I'm going to include that in the next page. Okay, now I have to clear the page. So let's start solving. So what we have taken out the area as pi r square upon 3 plus, so we don't have taken out the area of these two flaps. So 2 into area of A I'm using for area of these flaps. So how do we calculate the area of these flaps? So for this I'm going to again modify the diagram so that you have the better understanding. Okay, now I have again modified the diagram as you can see the screen. So I again write that these lengths are R. So what you can see in the diagram. So this is 60 degrees, which I told you, because they are APQ is an equilateral triangle. Okay. So and we want to take out the area of what? This flap. We want to take out the area of this flap. So we can say that, and if I include one more point like this, I include it as T. Okay. So we can say that the area of this flap, which we want to take it out, equals to be area of the sector APQTA minus the area of the equilateral triangle APQ. So don't think that I multiply some constant A. A stands for area. So for visualization, I am using A for area in this case. So what is area of APQTA? It is a sector, so it is pi r square upon 6. Pi r square upon 6, again, I am just telling you one in a quick way that the area of any sector is pi r square upon 360 theta. And angle is 60 degrees. So after when we cut the common factors, 61 are 66. So like this we have got the area pi r square upon 6. Okay. Minus the area of a triangle APQ. Well, if you have seen my last video, so you must be knowing that area of any equilateral triangle, if with the side, any side, let's consider side S. So area of any equilateral triangle equals to be square root of 3 upon 4 S square. But in this case, S equals to be R. So S equals to be R in this case because radius is R. So we can say that S equals to be R and the area equals to be square root of 3 upon 4 R square. 4R square. So now we simplify. After factoring out R square, from both terms we get pi upon 6 minus square root of 3 upon 4. I am actually factoring out R square outside. So there is R square in both sides as you can see in the screen. So I just factored out, keeping the minus sign as it is, and we get R square into pi upon 6 minus square root of 3 upon 4. Okay. Now as this in question 2 into 2 into because actually as APQ is congruent to PBQ because of SSS congruency. So actually this shape and this shape which was here is also same. So that's why 2 into. Then we get, so after multiplying we get 2R square multiplied by pi upon 6 minus root 3 upon 4. Okay. So this is one more last step. Now we have to add these both constants together. What we are going to do? We are going to just add pi square upon 3 with 2R square. We are just going to add that in the next page. And I am going to clear this background which I have just written right now. Okay, I cleared it now. So what are the two values which we have taken it out? So area of the sectors would be pi r square upon 3. And the area of this segment multiplied by 2 equals to be 2r square multiplied by pi upon 6 minus root 3 upon 4. So now last step we are just add them up to get the total area. We get pi r square upon 3 plus 2r square which is outside the bracket and multiplied by pi divided by 6 minus root 3 upon 4. So now we can factor out r square from this expression now. After factoring out, what we get? So after factorization we get r square multiplied by pi upon 3 plus 2 multiplied by pi upon 6 minus square root of 3 upon 4 and 2 brackets together. So in this case I have actually factored out r square in this case, but now I have to distribute to it. So after distribution, what we get? So we get, after distribution, we get r square multiplied by pi upon 3 plus 2 into pi upon 6 minus 2 into square root of 3 upon 4. Please note that there is a plus sign, so I can open the bracket directly, so I don't have to change the signs like we do in the minus. So we have to not do that, so we can just directly solve it. Now after cancelling some common factors, here 1 and here we get 3. 2 ones are 1. So 2 ones are 2, then we get 2 twos are 4. So after that, after simplification, we get r square multiplied by pi upon 3 plus pi upon 3 minus square root of 3 upon 2. So at the last, now we have 2 now, that we have 2 the same thing. Pi upon 3, it is repeated 2 times. So we can just multiply it by 2 and we get r square multiplied by 2 pi upon 3 minus square root of 3 upon 2. So that's the answer of our question now. So I am highlighted the question and this is the answer. So now I hope that you understood that how we have got this area and how I applied this formula to the question which I have covered in the previous video. Thank you for watching.
Thank you for watching this video. If you like our videos of our channel, please subscribe to our channel and don't forget to ring the bell for more educational video notifications of our channel.